Okay, so welcome to the fifth video for section 8.4. So definition. So a cardioid, that's what we're defining. A cardioid, meaning heart, is a polar graph of the form number 1, r is equal to a plus or minus a sine theta, which as above is oriented either up or down. Or number 2, r is equal to a plus or minus a cosine theta. So that's x-axis, so that'd be right or left. Where the side radii, remember radii is plural for radius, so side radii will have length a. Large radius has length 2a and intersects the pole. Okay, so let's go ahead and plot one of these, or how about 4 of them? So for example, plot the following cardioids. So number 1, say we're given r is equal to 2 plus 2 cosine theta. And let's say I didn't have any of the guidelines I have up here. So what I'm going to do is I'm going to set up an r comma theta chart. Actually, maybe I'll move it over a bit. Theta. So usually I like to start theta at 0, then at pi over 2, then at pi, then at 3 pi over 2. Okay, so in the first case, at 0, this will be radius is 2 plus 2, which is 4. In the second case, radius is 2 plus 0, which is 2. In the third case, radius is, actually let me put this on along the same lines, I think that'd be easier. Nope. Okay, so in the third case, this is going to be 2 minus 2, which is 0. And in the fourth case, this is 2 plus 0, which is 2. Okay, so these are 4 coordinates I have so far, given in polar form, r comma theta. And let's see if they correspond to the directions. Okay, so this is cosine and it's positive, so I'm assuming it's going to be oriented to the right. So I'll give myself room to the right. And I think I'll draw this a bit larger than normal. So x and y, so let's do 1, 2, 3, 4, 1, 2, 1, 2. Okay, so at 0 radians, my radius was 4. At pi over 2 radians, my radius was 2. So at pi radians in the direction of pi, my radius was 0. At 3 pi over 2 radians, so in the direction of 3 pi over 2, my radius is 2. So what we get is a heart-shaped graph that looks something like so. And notice, well, it's a terrible graph. Hold on. Let me draw this a bit better. It's kind of difficult to draw. I like to call this, yes, well, if I could draw it, which maybe I should have made it as small as it should have been instead of trying to make it too large. I call this a gluteoid, even though they call it a cardioid. I think it looks more like a gluteoid, but anyways. Okay, so here's our quote. No, it's not. It's symmetric. So let me make sure. Okay, that's as good, clearly as good as I can get it. No, it's upsetting me. I'm going to try it again. Hold on. One last time. No. Really? Okay. You know what? Okay. Yeah. This is just terrible. I don't know why I cannot draw this. Because I made it too big. That's why. Okay, good enough. Okay. So notice that this is oriented to the right. Because it's positive cosine. So the large radius that I was talking about is twice a, namely 4. The side radii are a, which is up and down, here 2. So notice that this has length 4 for my large radius, and it has length 2 for my side radii, and it intersects the pole. Okay, so without any work for the next guys, since I know positive cosine is oriented right, it would make sense that negative cosine is oriented left, and it would make sense that sine is oriented up-down. So without further ado, and without having to plot all these points, let's do number 2. Or maybe I'll do it just to build a character. Let's say we have radius is equal to 1 minus 1 cosine theta. So once again, I could do my r theta. So this time let's have theta be in orange. So 0, pi over 2, pi, 3 pi over 2. So the corresponding radius will be 1 minus 1, which is 0 for the first term. Then 1 minus 0, which is 1. Then 1 minus a negative 1, which is 2. Let me move that over a bit. And finally, 1 minus 0, which is 1. Okay, so these are the 4 points I have in the 4 directions. And let's see if this is indeed left, because it's minus cosine, with a large radius of twice a. Well, a is 1 in this case. So x and y. Let's do 1, 2, 1, 2, 1, 2, 1. Okay, so we have radii of 0, or angles of 0, pi over 2, pi, and 3 pi over 2. I know at an angle of 0 radians, my radius was 0. Okay, so in the direction of 0 radians, my radius is 0. In the direction of pi over 2 radians, my radius is 1, so that's up. In the direction of pi radians, that's to the left, my radius is 2. And in the direction of 3 pi over 2, that's down, my radius, as measured from the pole, is 1. So what I should get is my gluteoid / cardioid thing that looks like. So notice that this is oriented left because it's minus cosine, right? And do you agree that my large radius is 2 and my side radii are 1? A, each of my side radii are just 1. And I intersect the pole. Okay. Okay, so let's see. Let's do now sine. So for example, number 3, let's say we have r is equal to, maybe 3 plus 3 sine theta. So I claim that this is up. And 2a equals 6 and a is equal to 3. So without further ado, x and y coordinate axes. One, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. So I claim my side radii are 3. I intersect the pole, and my large radius is 6. So I claim that this is up. Where my large radius. Let me try this again. Try and make this a bit of a better graph. Why do I... it's so difficult to draw these well, as you can see. Okay, let me try again. I know I'm being obnoxious, not that it matters, but I would like it to look somewhat neat. That's not how to do that, okay. Okay, well, you kind of get the idea. So this is oriented up because it's positive sine. My large radius is twice a, or 6, because a is 3. And my side radii are each 3. And I intersect the pole. Okay, let's do the next one, number 4. So let's have radius be 2 minus 2 sine theta. Okay, because of the negative, I claim that this is down. So twice a, in this case, is 4, because a is 2. Okay, so sine, my large radius is only 4, so I don't need that much room. X and y, 1, 2, 3, 4. My side radii are 2, and I intersect the pole. So large radius of 4, side radii of 2, intersect the pole. So it should look something like so. No, it shouldn't look like that. Okay, let's see. Nope. Okay, something like that. Okay, notice that this is oriented down because it's sine, it's up down, with the large radius being 4 and the side radii being 2. Now you don't have to draw these little blue guys. I'm just trying to illustrate. Okay. Okay, so I think, I think I'll stop here with cardioids, and we'll do Lie